everyone, you're welcome back to my channel. My name is Helen. Thank you so much. If this is your first time, I really appreciate you. If you're coming back to my channel, I really appreciate you as well. So today I'm gonna be walking you through step by step on how to deploy a 3-tier web application on AWS. So today this project is actually focused on high availability, redundancy, security, scalability in AWS and others. So you'll be learning a lot from this project. Okay, so if you want to have hands-on experience, you want to pass your AWS Solutions Architect exam, and you want to see how this is being implemented in real life, stick till the end of this video. Okay, so please, if you're yet to subscribe, kindly subscribe to this channel. All right, subscribe and click on notification bell so you don't miss any video, because I have a lot to share with you guys. All right, so if you're ready, I'm actually ready. Let's get started. So first of all, what is a web tier? A web tier is actually responsible for presenting information to the user via a web interface. It typically consists of a web server that receives updates or requests from the user's browser and then returns the requested web pages. For instance, if you go to an online store or an e-commerce website to purchase a smartphone, for instance, okay, so if you go to the online store, once you click and request for that list of you're gonna see list of smartphones. Okay, so that interface, that graphical interface that is being displayed to you, that is the web tier. Okay, so it is responsible for handling users interactions and displaying data to the user. You make a request and it will display whatever you've requested for. So that is actually the web tier. Let's see what application tier is all about. Application tier is actually responsible for processing user requests and then generating responses. So it typically consists of one or more application servers that run application logic and access backend systems or databases. So this application tier is responsible for implementing business logic and application workflow. So basically what happens here is that in application tier you have application servers, okay, that is actually running your application. So this is where the business logic happens. All right, and this application tier has access to your backend or to your database. Okay, so that is actually what happens at application tier. Now let's see what data tier is all about. Data tier is responsible for storing and retrieving data. So it typically consists of one or more database servers that store data in a structured manner and provide mechanism for querying and updating data. So basically this is responsible for ensuring that data consistency is ensured and then providing efficient access to your data. I'm gonna paint a scenario in a moment. Consider an e-commerce website or online store. Okay, so what happens at the web tier? So at the web tier in an online store, first of all, I want you to see the web tier as a front door of the store. That is just the front door, first of all. All right, so when you want to buy something, you go through the store's website, and then the web tier shows you the product that is available or the products that are available. All right, so this is where the store's display window shows you what is obtainable, what the store has, okay, depending on the request. So the web tier is responsible for presenting that store's product and services to you, handling the user's interactions and then displaying those data to the user or to you as the person that is requesting for that. Okay, so this is basically what happens at the web tier. Now what happens at the application tier? Using the same online store, so I want you to see the application tier as the store's salesperson. So when you want to buy something, you tell the salesperson what you want to buy and they will help you to find it. So in case of this the online store, the application team is actually responsible for processing your request and then figuring out what you want to buy. Okay, for example, when you add a product to your cart, let's say you want to buy a smartphone, um you want to buy clothes and all that, and then you keep adding those products to your shopping cart. Okay, so after adding to your shopping cart, the application takes care of updating your cart and making sure that the right product is added to your order. So this is what the application tier does for you. So the data tier is like the store's inventory system. When you want to buy something, the salesperson check the inventory system to make sure that the product is in stock. So in the case of this online store, the data tier stores information about the products that are available, the products that the stores has available for sales, the prices, and the description. Okay, so immediately you add product to your shopping cart, what happens is that the application tier communicates with the data tier to update the inventory system and make sure that the product is reserved for you. Okay, so there must be a communication between the application tier and the database tier to update the customer's information. So this is actually what this is the best way I can explain what the web tier, the application tier, and data tier is to you. Now let me take you to the architecture of this project. So basically we'll start by so we'll be running this project on a particular region, and then we'll create our own custom VPC. After creating the VPC, we'll deploy VPC components like the internet gateway, the NAT gateway, and we'll also have subnets. Okay, we'll have public subnets, we'll have private subnets, and we'll also, so basically we'll have public subnet for the web tier, we'll have private subnets for the application tier, and then we'll have private subnet as well for the data tier. So what will happen at the public subnet is that we'll be using a load balancer. So a load balancer is basically what we'll have here in the web tier, because it will actually help to balance traffic across our servers. All right, so what will be happening in this private subnet is that we'll be running our two application servers. All right, we'll be running two application servers in private subnet. Okay, so we don't want users to access this directly, so that is why I want to go through load balancer. When user try to access our application, it will be passed through the load balancer, and then load balancer will be the one to route traffic or distribute traffic across these two servers. All right, so like I explained in my previous slide, there will be a communication between the application tier and the database tier. So this is the data tier also in private subnet. Okay, so there will be communication between these servers, these two servers. There will be communication between the servers and the database. We'll be using RDS database. All right, well, RDS that is my SQL database in AWS, and this will also run in it will be a multi-AZ deployment. Okay, so this is just the overview of our architecture, and right now I'm gonna take you to AWS and let's start implementing this. So this is my AWS. I'm already signed in. I've signed into my AWS management console. So the first resource we'll be creating is VPC. We'll be creating our own VPC. So what I would do is to type VPC here, and I'll click on VPC. I'm gonna click on VPC here, and if you see what I have here, I just have one VPC, and this is the default VPC. So I'll go ahead and click on create VPC, and I'm gonna type the name as awsproject VPC and scroll down. The IPv4 side I'll be using is 10.0.0.0/16 and tenancy is default, so I'll go ahead and click on create VPC. And the VPC has been created. If you check here, you see that the project VPC has been created. Alright, so the next thing I will need to do is to enable host name in this VPC. So I'll select the VPC I've created here, and in action I'll click on the drop down, and I'm gonna select ADVPC settings. Okay, so I'll scroll down and I'll enable DNS host name, and I'm gonna save this. Alright, so this is done. The next, so having created VPC, I'll go ahead and start creating the VPC components. So the next thing I'm gonna be creating here is internet gateway. So internet gateway is here. I'll select it, and actually I have internet gateway already here by default, so I'm gonna create internet gateway. Okay, and that is that. It's just very simple to create. So I'll click on create internet gateway. Alright, having created this internet gateway, the next thing I need to do here is to attach the internet gateway to the VPC I've created. So how do I do that? You can see this action here. Just click on that and you see attach to VPC, and you select the VPC you want to attach this to. This is project VPC I created, so I'll attach the internet gateway. So having done that, the next component we'll be creating here is subnets. So we'll create 9 subnets. The total subnets we'll be using in this project is 9. So we'll first of all create 3 public subnets, which is for the web T, okay, and then we'll create another 3 private subnet for the application T, and lastly 3 private subnet for the data T. So let me go to this is my subnet here. I'll click on it, and then all the subnets you can see here is actually the default subnet. So I'll go ahead and click on create subnet, and I'm going to select the VPC we've created, which is project VPC, and scroll down. I'll type the subnet name. So I'm gonna be following a particular naming convention. So I'll start this way: public subnet AZ1. I'll recommend you follow this naming convention so you don't get confused. So public subnet AZ1 is for the web T. Okay, so the availability zone we'll be using for this is US East 1A. Alright, so the IPv4 side that I'll be using is 10.0.0.0/24. This is it here. Okay, so the tag is fine. So having created the first subnet, I'll go ahead and click on add new subnet here, because remember we're creating 9 subnets in total. So the subnet name, so the subnet for this is public subnet AZ2. Alright, the availability zone is US East 1B. Okay, so the first one is in US East 1A, the second one is US East 1B, and the CIDR for this is 10.0.1.0/24. Right, so that is it for the second subnet. I'll click on add new subnet for the third one. So this will be public subnet AZ3. The availability zone will be US East 1C, and the CIDR will be 10.0.2.0/24. And okay, so we are done with the public subnet. Now let's go to, I'll click on add new subnet. So we'll start creating our private subnet. So I'll be creating subnet for the application tier. So that will be private app subnet AZ1. Okay, so when you see me type AZ1, it means it will be in availability zone US East 1A. Alright, if I type 2, that is US East 1B. If I type 3, is US East 1C. Okay, so this private app subnet will be in US East 1A, and the CIDR will be 10.0.3.0/24. Okay, so let's add another subnet. Private app subnet AZ2. This is the second private subnet to be creating, and it's running US East 1B. The CIDR will be 10.0.4.0/24. And that is it. I'll add another subnet for the third private subnet for our application tier. So this is private subnet AZ1, sorry, AZ3. Okay, and the availability zone is US East 1C. The IPv4 CIDR is 10.0.5.0/24. Okay, so that is the private subnet for the app layer or the application tier. Now let's create the next 3 private subnet for the data tier. So private DB subnet AZ1. The availability zone is US East 1A, and the CIDR block is 10.0.6.0/24. Alright, and I'll click on add new subnet, and this will be private DB subnet AZ2. This one is US East 1B. The CIDR should be 10.0.7.0/24. Okay, and lastly, add new subnet. This is private DB subnet AZ3. The availability zone is US East 1C, and the CIDR is 10.0.8.0, sorry, 8.0/24. Okay, so let's review what we've created. To please ensure that all this the CIDR block is correct and the naming convention. So have public subnet AZ1 in US East 1A. The CIDR is fine. public subnet AZ2, US is 1B, decider is fine. Public subnet AZ3, US is 1C, decider is fine. Okay, private app subnet AZ1, US is 1A, decider is fine. Okay, so please check this thoroughly and ensure you are not making any mistake. Okay, so I can see that I didn't add private subnet AZ1, private app subnet AZ2, private app subnet AZ3. Okay, so I should add app here. Private DB subnet AZ1, private DB subnet AZ2, private DB subnet AZ3. Alright, so I'm gonna go ahead and click on create subnets. Awesome, the subnet has been created. So you can see all the 9 subnets are here and all running. Alright, so what is the next step here? The next step is to enable auto assign IP address for our public subnet. So we have three public subnets. So for the 3 of them, we'll be enabling auto assign public IP address. So once you select the public subnet, okay, once you select that, come to action and click on it. Click on edit subnet settings and enable auto assign public IPv4 address. Save it. We are doing this so that public IP address will be assigned automatically, okay, because this is a public subnet. So I'm gonna select this other one and do the same thing. Enable auto assign IPv4 address, right? And lastly, I'll be doing that for the 3rd public subnet. Alright, so we are done with subnets. Now the next thing is to go to route table. We'll be creating a route table. I'm gonna click on route table here and I'll click on create route table. So first of all, we'll be creating a public route table. So I'm gonna name it public route table and select our VPC, and that is all. I'll create route table. Okay, so this public route table is for the web tier. All right, so after creating this, I'm gonna go ahead and create the second route table, which will be a private route table, and this will be for our application tier. So click on route table, create route table. I will name it private route table. Select the VPC, and I'm gonna create, okay, let me actually, because this is for the app T, so let me differentiate this from the next one we'll be creating, because we'll create private route table for our database tier. So this is for app tier. I'll click on create route table, and lastly we'll be creating the next private route table for our DB tier, database or data tier. So private DB route table, select VPC, and I will create. Alright, now we're done with route table. Let's go over to NAT gateways. NAT gateway is just right here. Click on NAT gateways. So I don't have any right now. I don't have any NAT gateway. Just click on create NAT gateway. NAT gateway is one, and please note you create your NAT gateway in the public subnet. Okay, please take notes. You create your NAT gateway in the public subnet. So even though you'll be using NAT gateway for just like a gateway for your resources in the private subnet, you have to create it in the public subnet. Okay, please take notes. So I'll be selecting the public subnet AZ1, rather public subnet AZ1 is here. All right, so scroll down. So we'll be allocating an elastic IP to this NAT gateway. So just click on allocate elastic IP. So we can have a static IP address, and that has been allocated. So click on create NAT gateway. Okay, so now that this NAT gateway has been created, I'm gonna go to public route table that we've created, which is here. Click on route table and select this route table. So I want to give a route to this public route table. So this route table will be using internet gateway. Okay, so the routes will be internet gateway. So once you select public route table, you come here, click on routes, and just right here you see edit route. Click on it. So here just click on add routes and select from anywhere and click here, select internet gateway. Once you click on internet gateway, the one you created will be shown here. Okay, I need to select it again. Internet gateway, select internet gateway and save changes. Alright, so I'll need to then associate public subnet with this public route table. Okay, so this public route table, we've added a route. The next thing is to associate public subnet. Remember, we have 3 public subnets we've created. So just come to this tab and click on public subnet, and then have to scroll down and you see edit subnet association. So here look for public subnets you've created, 3 of them. Please ensure you select the public subnet, the 3 public subnets, and click on save associations. Okay, so the next thing is to go to our private route table, and this is the private route table for our apt. So once you click on it, let's add a route to it as well. So I've clicked on route, and just beneath here you see edit route, add route, select from anywhere. So right now we'll be making use of NAT gateway. Okay, remember this is for our application T, so we'll be making use of NAT gateway. All right, so just select NAT gateway and select the NAT gateway you've created and save changes. Okay, so having done this, select the same private app route table and click on subnet association. So we'll be associating the 3 subnets we've created for our application T. We'll be associating it to this route table. So just click on edit subnet association and select private app subnet, the 3 private app subnets you've created. Private app subnet, okay, and save associations. All right, so now we come over to the private DB route table. Let's add a route to it. So actually you should have another NAT gateway. Remember, we just created one NAT gateway. Ideally you should have 2 NAT gateways in this case, so you know, for redundancy, right? So but we'll be making use of the same NAT gateway for this for the database tier. Okay, so just select it, come to route and click on it. Click on add route, and here select NAT gateway, click on NAT gateway and save changes. Alright, so let's check what we've done. Ensure that everything is running well and that you actually configure this well. Okay, so if you don't review what you've done, probably you might be omitting something, but I'm sure I really got all I did correctly. So let me check the route. So we added private, let me start with the public route table, and on the route tab I can see the internet gateway I attached here. This is the default one. Okay, and if I check the subnet association, right, these are the public subnets I've associated to my public route table. Okay, so let me check the second one, private app route table. The route should be NAT gateway, and that is it here. So let me check the subnet association. So I have private app subnets. The 3 private app subnet for our application T is fine. And lastly, let me check for the private data route table. The route is NAT gateway, and subnet association should be the subnet for, okay, we've not actually associated the subnet. So right now click on edit subnet association. Let's associate the private DB subnet, okay, the 3 of them. So select the 3 of them, so you can never be so sure. So please ensure you review what you've done before you go ahead. All right, so save associations, and that is it. So if I click on private DB route table now, check the subnet associations. As you see, the DB subnets, the 3 of them. Okay, that is fine. So that is it for the network connectivity. So we are done with this phase. Now let's move over to the second phase. So we'll be creating an EC2 instance for our bastion host. So we'll be making use of a bastion host. And what is the essence of making use of a bastion host? A bastion host basically is a server that provides secure access to other servers that are not directly accessible from the internet or other networks. So we don't want our application servers to be accessed directly. So we want, because of security, okay, we'll make use of a bastion host. Okay, so the primary purpose is to secure or to create a secure access to connect to other servers you have, which are actually in the private network. Okay, so we'll have our application tier running in private network, so we don't want to really risk it. We want to use a bastion host for secure access. So I'll go ahead to EC2, and once you type EC2 here, click on EC2. Okay, in this dashboard, I'll scroll down and click on launch instance. I'll name this bastion host. Scroll down. So be making use of Amazon Linux 2, select it. T2 micro is fine for the instance type, and the key pair, create a key pair. Give your key pair a name. Okay, and it's fine. The private key file format is fine. I'll create a key pair. Okay, so it is already selected here. I'll scroll down and click on edit network settings. I'll select the VPC we've created, and this subnet will specifically pick the public subnet AZ1 because we like our server, our bastion host to be in public subnet AZ1. Okay, and scroll down, we'll be creating a security group for this. Okay, so here I will name this bastion host SG. Use the same name as my description. Okay, so the SSH rule is fine, so I'm gonna leave it this way. Scroll down. That is basically what I need to do here, and I'll launch instance. Awesome. So let me click on view all instances. While this is creating, I'm gonna go ahead to start launching the application servers. Okay, so this will be app server 1. We'll be using Amazon Linux 2. T2 micro is fine. Be using the same key pair, which is project key pair we created. So I'll click on network settings. So select the project VPC we created, and so here I'll go ahead and select private subnet because this should be deployed on the private subnet, the private app subnet. So I'll select private app subnet AZ1. We'll also be creating a security group for this, so I'm gonna name it app server SG. Use the same name here. Scroll down. SSH rule is open already from anywhere. Okay, so because we like the jump server to have access to this application server, so we'll be selecting the rule here. So from this source, just click on the source here. First of all, select custom and click on source. So check for the jump server or the bastion host. Sorry, I'm using the word jump server, but they're the same thing. Okay, so the bastion host, so is it that you call it bastion host or jump server? So select it because we want it to have access to this application tier or the application server. Okay, so that is it. I'll go ahead and click on launch instance. All right, so this is in a pending state. Let's go ahead and create the second server for our application. Name this app server 2. All right, the same Amazon Linux 2. Instance type T2 micro, key pair, the same key pair. Click on network settings, edit network settings, and the VPC, select the VPC we've created. So the subnet we'll be using right now is private app subnet AZ2. Okay, so here we'll be selecting existing security group, and the security group we'll be using is the same security group we use for our first app server 1. So this is it here. Alright, so I'm gonna go ahead and launch instance. Alright, so the bastion host and app server 1 is running already. So I'll go ahead and connect to the bastion host. Okay, so we'll connect to the bastion host, and through the bastion host we can then connect to our app server. So I'll copy the public IP address of the bastion host, and I'll go over to my terminal. Okay, so first of all, remember we created a key pair, and the key pair was actually downloaded to my computer, and it will be the same in yours. So I'll check the key pair and ensure that I copy it. So what I'll basically do is to copy it and paste it to the path that my terminal opens to, because if I type pwd here, this is my path, so I'll ensure that I copy that. If it's in my download folder, I'll copy it and paste it in this path. Okay, so you should do the same. Okay, sorted. So I'm trying to avoid making this video too long, so I have the key on the path, right? So this is your key pair name, and you append the .pem. By the way, I'm using git bash. Okay, so type username, which is EC2 user, and okay, and I've connected to my bastion host. The next thing we actually need to do now is to connect to our application server. All right, so the app server 1 is what we need to connect next. So I'm gonna go to my app server 1 and copy the private IP address. You can actually click on connect here. Once you select it, click on connect, then you can get the information here you can use to connect. So I'll copy this, go to my terminal. So before I run this command, I actually need to have this project key pair in the file here. Like, I need to create a file and add it, because if I run this command, there will be a permission issue. So just all you need to do is to go to So all you need to do is to copy just copy the content of the private key you downloaded, the private key pair you downloaded to your computer. Just open it, copy the content. Okay, so we'll create a file and add the key pair. So vi key pair. Okay, so over here I'll be pasting the content of mine. Right, I'm gonna save this, and then now this is the right time to run this command. Chmod 400, so we can give permission to this file. So chmod 400 keeper right. So I can go ahead and copy the SSH command to connect. Permission denied. So what you do is to copy the content of the file. Okay, so right now we'll be connecting to the app server 1. Okay, we'll be connecting via this bastion host. All right, so right from here I'll run a command to connect to the app server 1. So what you have to do is to select the app server 1, click on connect here, so you can get the command. It's actually the same SSH command we ran. Okay, so this is the private IP address of the app server 1. So just copy this and go back to your terminal. But before we run this command, so we actually need to have the key pair we've created. Okay, remember we use the same key pair for the servers. All right, so you need to have the, if I do ls now, we don't have a file here, so we need to have that key pair file. If not, if I run this command, there will be some error. Okay, there will be permission issue. So I have to copy the contents of my key pair. Okay, so what you do, just open your key pair in any location that it is, just open it and copy this. Come here, so I'll run vi key. I'll basically use the same name, okay, which is project key dot spam, and over here I'll paste the private key, and I'll save this. Okay, so having saved this, let's give it the necessary permission. Chmod 400 project key dot spam. Right, so right now I'm gonna copy the command to connect. All right, so we connected successfully, so we're able to connect to our application server, that is app server 1. Awesome. So having connected, I'm gonna show you the next thing we need to do. We'll first of all start by updating our package manager. Okay, sudo yum update. So I'm gonna take you to AWS documentation, where we'll be installing, so basically we'll be making use of a lamp stack. Okay, so we'll be making use of a lamp stack. This is Linux, Apache, MariaDB, and PHP. Okay, so basically we'll not be making use of MariaDB because we'll be using MySQL RDS MySQL in AWS. Okay, but we'll install others, we install the dependencies and everything. So this is actually the documentation to use. Okay, so we'll start by sudo yum update, but I've actually copied out all this command here, so I'm gonna be copying this from here. So first of all, let's update our server. Okay, while this is updating, so now we will install the dependencies. The Amazon Linux extra repositories to get us the latest versions of LAMP, MariaDB and others. So copy this, go to my terminal. So this update is completed. I'll clear my screen. So I'll run this command. While this is getting executed, let's install Apache Web Server. Okay. Right, Apache Web Server is completed already. Let me clear my screen. So we're gonna start the Apache Web Server. Okay, and next we'll enable Apache Web Server. And this has been enabled, so we have to confirm that this has been enabled. So I'm gonna run this command. As you can see, enabled. Fine. So we use this command just to confirm that the server is working. Okay, so I'll run this and the Apache Web Server is actually up and running. Okay, if this is not what you see in yours, then probably you're getting something wrong. Okay, let me clear my screen. So the next command here is to add our user to the Apache group. Okay, so the user is EC2 user, which is the default username for our Amazon Linux. So add the user to the Apache group. And that is done. So now to take effect, I'm gonna log out and log back into my server, and then I'll be verifying the membership in the group, in the Apache group. Okay, so type exit and connection is closed, so I'm gonna use the same command to connect back. All right, so I've reconnected to my app server 1. So the next instruction here is to change the group ownership of /var/ww and its content to the Apache group. Okay, so let's change the group ownership with this command. Interesting. Okay, so let's add group right permissions and then set the group ID on future subdirectories. Okay, remember whatever I'm running here is what we have there in the documentation, so you can follow the documentation as well. So now we want to add the group right permissions. Okay, recursively, in order to change the file permission of /var/www and its subdirectories. So I'm gonna copy this, paste this here, and press enter. Awesome. So right now the next thing we need to do is to install php my admin. What is php my admin? Is basically we'll be using it as a simple web application. All right, let me clear this. So to install that, I'm gonna copy the command here, paste it here, great. So we'll be restarting our php. Okay, we'll be restarting the Apache, sorry. So to restart Apache, copy the command, right, and then we'll restart php fpm. I'm gonna copy the command, great. Let me clear this screen, and the next command is to navigate to the Apache document root. Okay, so we have Apache root document at /var/www/html. Okay, so I've switched directory to this. You can see it is actually empty. So here we'll be downloading the php my admin package. How do we download it? I'll just get the command from here, press enter, and it has actually downloaded the php my admin package. Okay, how do you check that? Just type ls, as you can see it has downloaded. So having downloaded my php admin package, the next command is to create a folder. So we'll be creating php my admin folder that can help to save the content of the package for us. So the next command we'll be running is to basically create, let me copy this. So this command will create a folder and then extract the content of my php admin package into the folder. Okay, I'm gonna run this, and this is done. Let me clear this. Okay, so if I run ls command again, you can see the folder has been created. So the content has been extracted into this. So I can actually go ahead and remove this tar file here because we've extracted what we want. So just run this command rm, and that is it. So now we only have the folder and the php my admin package. All right, so so that is it for this app server 1. So I'm gonna go ahead and do the same installation for the same setup. Okay, so whatever I've installed or whatever I've done in this app server 1, I'm gonna do same for app server 2. So all you need to do is to, okay, let me go back to EC2 instances. So this is app server 2. Just click on connect and copy the connection command, and so just exit from here. And right now I'm in the bastion host. Okay, so from this bastion host we'll be connecting to app server 2. Okay, I think I didn't copy the command very well. Okay, yes, I want to connect, and now we are in app server 2. So whatever I've installed right from updating my server, that is what I'm gonna do here. But I'll be pausing this video, so I don't want it to get too long. All right, so just do the same, and I'm also gonna share the command I used. Okay, even though it's in the documentation, but for clarity I'm going to be sharing this command. Okay, so just go ahead and execute it till this to the very last command we ran here. Okay, and mind you, you can actually use an auto scaling group in AWS to do this, okay, in order to reduce the manual effort. Okay, but we are not using auto scaling group. Okay, so just have that in mind, that you can actually use auto scaling group to help you auto scale your servers. All right, so I'm gonna see you in the second part of this video. Thank you so much.